non-degradable components. So when we do wastewater treatment, our goal is to stabilize the wastewater and remove the solids so that when we discharge it, it doesn't impact the stream. If we don't do that, what ends up happening is that stuff goes into the stream and microorganisms there work on it and it drops the oxygen in the stream, kills fish, that kind of stuff. So we try to take care of that before we discharge it. So it's just regular water that going into that stream as much as possible. Um, Inside the plant, this is a little schematic of just a general wastewater plant, but once it flows in, usually you want to go through screening and grit removal to try to get anything that is fixed or big out so that you don't even have to worry about that. And then it flows into aeration basins where microorganisms try to eat the degradable substances, either it's stuff that's dissolved in the water or some of those bigger solids. And then settling to kind of trap whatever solids they can remove and clarify the water. And then finally to disinfection where anything that's small that's still in there gets disinfected. So if you come into contact with that water as a human, you're not going to be made sick. So, and then the final stuff that's off to the side is kind of like the side stream. We take those solids that we've settled and digest them to try to stabilize those further so that they can ultimately go to land application. So that's kind of a brief overview of what wastewater treatment is. There's lots of ways to do this. So in Solon right now, on the next page, you have the existing plant. Just kind of take you through this a little bit. This existing plant, it was built in the 1950s. Not in the current state that it's in. There are a few original buildings that have been modified, but it was expanded around the late 70s to what I would say is pretty much the same kind of treatment that's there now. So you have the same treatment you've had since the late 70s, roughly. And then it was enlarged for additional capacity in 2005. Inside that plant, if you go to the next page, I kind of took that schematic that I had done of the people in the audience of that facility. And I'm noting with big red X's things that Solon's plant doesn't have. So it doesn't have any screening or grit removal. Wastewater comes in, it goes through these pumps that chop it up and send it directly to the aeration basins. So you're missing the opportunity to remove the solids that are fixed. And also it causes some problems with the pumps oftentimes through the process. And also solids will then accumulate, big chunks and rags and stuff will accumulate out in these aeration basins, which is a maintenance issue for the city staff. And then also in this diagram here, we've got the disinfection shown, but the one that's shown there is an ultraviolet. But what Solon is using is chlorination and dechlorination. So they use gas chlorine and sulfur dioxide to chlorinate and then dechlorinate so that it's safe so you're not killing anymore. Just from a handling standpoint. Additionally, Solon's wastewater facility is at its design capacity. The site currently has some issues with flooding, as part of it is in the or below the 100-year floodplain. And it's also got pretty limited room for expansion at that site due to site separation requirements. DNR requires you to be 1,000 feet from a habitable building or maintain 90% of the existing distance if it's less than 1,000 feet. So where the wastewater plant is currently located is pretty close to a lot of homes. So, and some geographic challenges as far as, the rock shelf and stuff nearby as well. So that all led to consideration of potentially looking at other sites for location of that facility. There's also the future growth areas of Solon to take into account. Solon is a growing community and is projected to continue growing. We included a map that kind of shows The little star is the existing wastewater facility. And then there's a big star for a potential future site that would also be able to serve those communities in red. That's right, Dave. Am I remembering your map correctly? Okay.
So if you're familiar with how this works right now, we have Trail Ridge Estates that has a lift station that pumps over here. We also have Old Mill Creek, the west half, that pumps over into Mill Creek, and that flows to the wastewater plant. As we get further west, we have the west branch of Mill Creek that flows down, and by gravity, we could service that area. That's that area shown in red on this future growth area map. A large part of this green area is outside the current city limits, so we have a lot of room for growth. We built that north trunk sewer. That north trunk sewer was set up to be able to handle that area in green. So we have a lot of growth area we can take in. And part of the issue with this existing site having limited space to build because of the site separation distances, we could spend a lot of money to get to a point where we might get a little more capacity out of the plant. But we're eventually going to see quite a bit of this growth happen, and we won't have room at that site to accommodate all of it. And at some point, we're going to have to make the switch. And it made sense at this time to try to get that area out by Trail Ridge, preserve that and look at building this plant. We're never going to be able to build it cheaper than we are with today's dollars. Had we done it 20 years ago, we would have done it with the dollars at that time. And cost continues to go up roughly 4 to 5% per year, roughly, on construction costs. When we look at Engineering News-Record. So the discussion was, where do we make that leap? At what point does it make sense? And to put a bunch of money into a plant that is not going to be able to continue to grow, that didn't seem like a good choice. We also have a lot of restrictions working around the existing facility. A lot of that piping was set up for a much smaller plant. The lift station doesn't have the screening. So to try to bring everything in there and get that updated while maintaining that plant in operation, those costs per what you get is a lot higher than if we just went to a new site and started that plant now, knowing that this one was not going to be able to handle continued growth. So a lot of that came into play along with the issues that Emily mentioned with the flooding. When we do have flooding out there, which happens every so many years, we can't get into the plant because the access road is flooded. That creates some issues as well with the operation of the plant. If we have a power outage because of the flooding and we're relying on generator, we can't get fuel in there because the access road is flooded. So we have limited runtime. Just different things that happen down there that led us to looking at this new site. So
I was just gonna say, so if you flip to the next slide, the design criteria, one thing we wanted to go through is DNR, when you do an upgrade, requires you to project out 20 years. So we looked at the existing plant capacity, and compared that to the existing flows that you were actually receiving. These are in 2023 when the planning originally started for this. And you can see when you compare those two columns, basically we're at capacity right now. That doesn't mean that the treatment plant will fail right away, but it does limit you somewhat to expansion, growth, that kind of thing. And if you start having violations, then you could be in a real bad position. So right now they're able to still, we're just basically right at capacity, and there is a lot of, I would say, conservative design measures in place that will allow it to keep functioning while we get through this period. But Solon really does need to be making a move forward to either expand and upgrade their existing facility or a new one. So the new plant capacity that we projected, we went through 2050 because by the time we go through all this planning and building process, we lose, 5 to 7 years, I think, somewhere in there. So we actually project out, this one's, 27 years instead of 20 because of all that planning period. And we went to a population of 10,000, just in discussions and comparing to communities in the area that we've seen grow. That seemed like a reasonable number. And one thing that happens in that jump also that also pushes us towards an expanded and new facility is you are going to be required once you get over, I've kind of highlighted in yellow there. But that's kind of when we talk about plant capacity, that's usually the number we're referring to. And at Iowa DNR, if you get over 1 million gallon per day flow on that AWW 30 that we show there, which Solon is not right now, but would be in the future, Now you're required to also address nutrients, which is nitrogen and phosphorus, and you start getting limits for those. So that requires a slightly different treatment method to address those items, additional treatment steps and processes. So considering all of that and the items that Dave's already mentioned, the city proactively looked at potential sites, and there was a new plant site that was selected that became available. And that's shown on the next slide. If you look where the red star is, we just included a photo and of where it is in location, the existing facility shown in blue, and then also just showing a photo of the open field there as it exists right now. So as part of this process, at looking at expanding the existing facility or moving to a new facility, the DNR requires an alternatives analysis to be done to justify the degradation if degradation is required. And generally, degradation would be considered required on any facility that is expanding or asking for additional permitted flow to go to the same creek. So even if you stayed at the same site, you would have to do this process. As long as you were asking for additional capacity. So as part of that, we worked through an alternatives analysis. And we considered 6 alternatives. Some were non-degrading, some were degrading. And those alternatives were compared and evaluated based on degradation, ability for future expansion of any facility we construct now, and cost. After the
Sorry.
Yeah, having some technical difficulties.
Sorry, we have this similar issue, planning and zoning last night. Second here. Okay, now try it.
Oh, it sounds better already.
Yeah.
I know, technology.
Yeah.
So throughout that period where we looked at all those probably took, 2024 and a good chunk of 2025 to evaluate all of those options and then to come up with costs and then review that with the city council. So after doing that for about a year and a half or so, the process was selected finally, which was a mechanical treatment facility with flow equalization. That process was selected because it meets the standards and also provides nutrient removal, which was one of the key items as the plan expands. It is similar to the current facility treatment process, but we have improved the screenings, grit removal, allowed for nutrient removal, solids handling, and also are planning to implement ultraviolet disinfection, which is typically a much safer process for the operators. And then it also included an equalization component to utilize the existing wastewater treatment facility as a peak flow storage and potentially accommodate some more flow range in the future, as well as maintaining that site for any future processes that might need to be added. And the big thing here is that this new site also allows for expansion and flexibility. So we've looked out past 2050, even into the future, and what we could do with that site. So, kind of going back to the original, on the next slide, then original treatment plant flow diagram that we presented. Now you see that we've removed a lot of those X's and warnings. And following a lot of the same process that's already there with those additional pump screening and grit removal facility at a headworks. So we kind of combine those, flowing through the basins into clarifiers, but the basins are a little more complicated, have a few more cells, that kind of stuff, to handle the nutrient removal. And then that UV disinfection. So that kind of, that has led us to our overall project, which is the next slide, which shows why we're here tonight. That's kind of the background on all of this, but existing site, to get from the existing site to the new site, we have a 30-inch interceptor sewer that needs to be constructed along Mill Creek. And then there we go. Is that it? Yep. And then the new plant site, so we've shown that. And then the reason it's in blue there is that's kind of related to the environmental review area that we're going to have to use. So that's the project area in a nutshell there. And the project timeline, like I said, we worked through 2023 and 2024 and even into 2025. So there has been a lot of thought and planning that has gone into this facility. The facility plan itself was submitted to DNR in October of 2025. And has been under review there. And we also submitted an application for funding using the state revolving fund loan program in December of 2025. And then future items are on here as well, but we'll get back to that in a little bit. The 30% plans were submitted to the city for some review at the end of March, and we met with city staff here at the beginning of April. And then there's another 60% plan submittal that will be coming in at the end of August for review as well. And then final plans and specs are supposed to be done by January of 2027, bidding in February 27. And then we have about a little over 2 year period for construction. So I'm going to pause here and ask if anyone has any questions on the background as we're going to transition now into the future and design.
On the state revolving fund loan, that's a loan, that's not a grant, right?
It's a loan.
That we'll have to pay back.
Yes.
The DNR puts all this stuff out there that we need to do, and within reason, there's no DNR funding assistance, correct?
There is some funding assistance, but they really limit that to what they consider to be disadvantaged communities, communities that are struggling to meet certain income thresholds. And where it would push the affordability criteria above 2% of the median household income. So they have some thresholds they look at. Solon does not meet those. We're in a fortunate situation that there's quite a few folks here that have income that's above that median household income. So
the other couple of things I have, as I look at the timeline, I'm sure there's not much we can do, but my concern is, as our world turns, costs. Is there anything we can start to look at right now to protect ourselves?
as far as trying to purchase stuff early or anything like that?
Globally, anything, but whether it's your time or to move the project, I'm just asking because that's what I hear out of this building. What can we do to help the overall project? Is there anything that can be done to help with the overall project costs?
So with the public bid process and with the DNR process and just the time it takes to put these together, we're looking at a pretty aggressive schedule with what we have. I don't know that there would be anything that we could accelerate and do this. We're still waiting on a few things with DNR. We're going through the environmental review process. That just takes time. That's probably going to be more of a driver as far as the schedule than us doing the design. And
Okay.
we're hoping to get through some of those things. We're engaging these folks early. We'll go through some of the environmental review findings that we've already gone through on our end to set DNR up to be able to review faster.
Okay,
But we really don't have any control over their schedule. Sometimes they have issues, government shutdowns being one of them. Those sort of things affect the Corps, they affect the DNR, they affect the agencies that have to do their background work.
sure.
And that's the overriding schedule that we're trying to stay within.
Okay. The only thing I would ask is, as we move forward, if there's something comes up that we can do as a council, help overall financially, don't be scared to bring it up, please.
And we've already been talking about rates. Cammy brought that up earlier, being proactive about trying to get things in place before
Yeah.
our first loan payment comes due. Anything we can do to help build up reserves, anything we can do to
Yeah.
try to limit the impact of the ratepayers, that's already being considered.
Okay, good, thank you.
Okay. If there aren't any other questions, I think we're ready for the second part, which is kind of where we're at now and where we've been going in the design. That was planning previously, so. The next slide in the group here is just showing that overall project again, to kind of remind people of what we have. And we're gonna be doing the existing plant site and the new plant site. We'll bid that probably as one contract, and then the interceptor sewer would be a separate contract, since those are different different types of contractors usually that are interested in that kind of work. However, the entire site, anything we touch has to be cleared as a whole, since it's receiving funding from the same source. So that's why that whole thing is in kind of a light blue, I guess, in our packets. The one of the first things that I was gonna show you is the future use and FEMA. So as we mentioned at the previous plant, there's some issues with flooding. So in this map, the blue shaded area is the floodway, which means we can't build in that. Correct me if I say anything wrong here. Dave's more the FEMA expert than me. But we cannot build in the blue area unless we can revise the flood map that FEMA puts out, which you guys just approved, I think, last December. And so that blue area is not really buildable area for us without some major revisions and permitting changes. And fortunately, we made some adjustments to the site that have allowed us to stay out of that area for the construction of the wastewater facility. If you look at that darker blue line that's to the, I guess I would say the north there, that is the 100-year floodplain. So that elevation there, that would be approximately where the flood would go in a 100-year event. And then the lighter blue line just north of that is the 500-year event. So there's not a lot of difference there. But you can see that that dark blue line kind of cuts through the site, and anything in that area would have to be built above that 100 years, so it would remain operational. So again, we've got the access road and everything to the north, so you're not going to have the same problems we have right now with access going forward. There's been some consideration and discussion of, you know, potential development along that access road for either future city buildings or possibly some parks, I believe. And that will really just come down to how best to utilize that area, but there's certainly potentially space for buildings to the north. As we get a little bit further to the south, it becomes a little more tricky because of that floodway.
We can place fill between the dark shaded area and that dark blue line, or even the light blue line. We've done modeling on that to show that we can put fill in there and it doesn't have a negative impact on the upstream properties. So that dark blue, we can put fill up to that area, but we have to preserve that dark blue area on the bottom. That indicates that we can expand our future plant, which are the lighter gray areas there. And then that small orange building is just an example of a public works building that would be able to store trucks too deep in there, and we could expand that left or right, even go south if we wanted to. So there's room there to play around with that and put in public works either lengthwise along the road, or if we wanted to go a little bit south, we could do that as well, just by placing fill in those areas and building that up above that either 100 or 500-year flood elevation. So that the important thing here is to see that we have quite a bit of room for other facilities. And we even talked about the possibility of throwing in some of those low-lying areas, some additional rec fields if we wanted to, and putting in some sort of a walkway from the south side going up there. And that might be temporary until we needed it for another use, whether that was a rec center or that was additional public workspace. But there's other uses for that property that we purchased. It's not just limited to the wastewater plant, and it is usable for building construction as well as putting some facilities in those lower lying areas and just kind of dealing with the flooding as it happens.
So, next slide, kind of mentioning the Iowa DNR review and approval process, as Dave's kind of hit on already a little bit. You know, that is a little bit outside of our control. We submitted the facility plan. Typically, that doesn't take too long to get approved. We submitted it back in October. They're still sitting on it right now. Due to some concerns they have about that site separation. So I've included kind of an aerial photo there that shows the site in relation to Trail Ridge to the northwest there. Legally, they're concerned that the property description or the properties are just described appropriately before they allow us to proceed with construction there. Because Trail Ridge was in planning, I believe, at that point. We have waivers on file. The concern is just being able to track it. So there's not, from our perspective, there's not big concern there, but satisfying DNR's legal team has proven a little challenging, I guess I would say.
So the last step that we're dealing with is on Tallgrass Drive, which is going to be part of Part 5, I believe they're calling it now. That's going to be just north of Part 3B. There are 3 lots there that are shown in light green. Those don't have a legal description because they haven't been final platted. So that's what they're trying to get. So we either have to create a legal description for them, we have to have Watts give us a waiver for the entire outlot that's there. And we're working through those 2 options currently. As soon as we get that resolved, that should be the last hurdle, but it's been a stepwise approach. There was a preliminary plat numbering that had the initial waivers. And then as each lot was sold, there was a final plat number that was associated with the lot sale, and they had a waiver at the time of sale as well. It's just that we have these last 3 that we need to have taken care of. So Kevin's working through that with DNR, and hopefully we get that done here in the next couple of weeks. But it's been a lot longer process than we had anticipated. And they just seem to have drilled down on that for some reason.
And that come due to all the changes that Watts makes with, they start off with this plan, then they change. It creates the snowball reaction of, it impacts a lot of things when that happens.
And DNR is concerned about this primarily just for the building. Once it's constructed, that's not going to be less of a concern because then you go to that 90% rule. But the concern is since that building is occurring right next to that development, those 2 are in such close proximity. They just want to be sure that somebody can't raise a claim, when we get halfway through construction. And so we appreciate that, but it has proved to be a little more challenging than typically. They haven't expressed any other concerns to us about anything that we're planning to do at the actual facility or with regard to the treatment process, but just concerned about that site separation. So we have been proceeding with our design. As part of this, because of the funding, we mentioned already, we're doing the environmental review process, and there has been a reviewer assigned. They handle some of the review, but not everything. So they're handling some parts. We have also been working with Eocene to handle some wetland delineation and identification of threatened and endangered species. If the one key thing is the DNR must issue a construction permit prior to breaking ground, and they will not issue the permit without the environmental review being completed. So, next slide talks about the wetland delineation that I just mentioned. The field work. The field work has been completed and the final report is expected soon. This was a preliminary, map that was just shared with us. So it may change slightly, but we're not expecting huge changes to it. So you can kind of see the areas that are potentially wetlands. Now, we did know that there would be some wetlands impacted by this, and I think most of these findings are pretty consistent with what we had anticipated. The city would have to decide how they're going to mitigate any damage sometimes on emergent wetlands and that kind of thing. They allow us just to simply replant and it's considered a temporary disturbance. Any forested wetlands tends to be a little trickier. Forested is really only in a couple spots that would potentially be impacted and it should be pretty minor. So, this doesn't look like anything that's too concerning right now anyway, assuming they don't find anything else between now and final.
So we'll attempt to limit the amount of disturbance to the forested area. To give you an idea, the credits are usually somewhere in the $80,000 per acre range to purchase the credits if we disturb the forested areas. The outfall down in the southwest corner is going to have a small area where the pipe has to extend out to that stream, that little oxbow. So we'll go through some of that forested wetland, but we'll keep that to a narrow swath. And then as we cross Highway 382 with the trunk sewer, we have to bore across that roadway. And there's going to be a large bore pit on the north side in that forested wetland area. We also have to construct a sewer over to the existing wastewater plant. So not all of that area gets disturbed that's shown there, but that just outlines the limits. And we try to, in those areas, keep the construction limits a little tighter, just so we don't have to pay for the extra. And then, that helps keep the cost down, but unfortunately, we will be going through some forested wetland areas that will require us purchasing credits.
And then the second thing that ESCN was working on for us is the threatened and endangered species, and they've preliminarily identified the northern long-eared bat and also the rusty patch bumblebee. I'm guessing the long-eared bat you've probably been through before on some other project. I don't know about the bumblebee, that's a newer one.
So we encountered this last year on a project and the two windows don't coincide. The rusty patch bumblebee in most cases is given priority. So even though we're clearing trees in the bat season, if we're avoiding the bees, they have that as the priority. So once we get that established through DNR, they'll tell us what our window is for taking trees down. And that just impacts the schedule a little bit. So we'll get all that spelled out in the specifications after we get our DNR reviewer to get all of that cleared with Fish and Wildlife based off of those findings.
And then additionally, we're also working on the next slide there, the geotechnical report. So we're working with Terracon to get that kind of assess the underground conditions. Terracon was out early part of May and did 23 borings at the existing site along the trunk sewer route and then also at the new site. And that is also expected to be completed soon. They did not encounter any bedrock. In a couple places we had them go down to 80 feet. Solon seems to have some pretty variable conditions with regard to bedrock. We had kind of wanted to verify there wasn't any on site. They did not find any. All the borings went down, I believe, or most of them went down to 30 feet at least below grade, never found any there. And we did a couple really deep ones to 80 feet, still nothing. So, we don't have a lot to share right now, but the final report is expected soon. And, depending on what happens there could be some cost impacts as always. Depends on what they find and what kind of soils we have there, whether they can support the tank structures or not. So we'll be in discussion and present that when we have more information.
The big concerns are the groundwater level, which they'll be able to tell us pretty quickly from the soil borings. And then also the compressibility of the soil. So if we put a heavy load on that soil and it'll settle, we have to identify how much settlement is going to be there, what that does for a large tank that's spread over a large area. So if one side settles and the other side is a little firmer, that's differential settlement. That's a problem because it introduces extra stress on the structure. and it affects, pipe connections and everything else. We need to make sure we understand what we're building on before we finish the structural design. And that's a critical component. They'll be able to tell us if we have to do any sort of ground stabilization. Geopiers, if you remember from the ground storage tank, when we did that project, they drill down, they put rock columns in, and those were compacted, as they came up. And those rely on friction, and that helps to stabilize the area. There's different ways that we can go about it, but those ground improvements, they do add cost to the project if we have to do them. There's other ways that we can take a look at doing this, but Terracon will provide those recommendations after they evaluate those soils, determine what the soil properties are, and how that would impact those structures.
And the next slide, we just want to highlight with the new site comes the running of new utilities. And one of the interesting things about this particular site is that we happen to be right on the boundary for the service areas of Corridor Electric and Alliant Energy. I don't think we could have picked a better spot to set it if we wanted to land on the boundary. After some investigation, we established that Corridor Electric will be the electric utility that would serve this site. It's basically based on where the load is, the majority of the load is. And since the majority of our plant is, it shows that little blue line that runs from north to south, that is the boundary. Since our plant is basically almost entirely on Corridor Electric service area side.
REC,
Lynn County REC.
Yeah.
REC.
Lynn County REC is now Corridor Electric. They changed their name.
I didn't know that.
Yeah, about a year ago. They did that.
And so because they're primarily west of that site, the nearest three-phase that we need to power the bigger equipment we have is from that direction as well. So instead of being able to run down 382 or having it already there, they can still run down 382, but it's quite a bit more service area. If you look at that map, they'd have to come down and then back across. They had proposed seeing if we could provide them an easement directly where we say that potential 10-foot shared utility, and that they had proposed that as a cost saving measure. If we could get that, they could not obtain that, is my understanding, but if we would obtain that for them, they would run it through there, and it would be a cost savings to the city. On top of that, we were looking at that also, gas service or natural gas to the plant. Mid-American would be able to access, I believe, from either direction, but it is a shorter path for them to come down from north directly to south, by about 500 feet. So again, probably a cost savings there. So, we've been discussing that with Watts, is that correct? So there is some potential there. But if not, we can use the access to off of 382. So it's not like we can't proceed with the project. There's just additional costs if we have to come that route. And then there will be it's not shown on here. It wasn't as big of a concern to us, but a water main will be coming from 382, just right next to near Wyndham Drive there. And we'll just bore across 382 and then run it down an 8-inch water main down the driveway there to serve the plant. So on the next slide, we're gonna talk about what we're doing at the existing plant briefly. So this existing plant that we're gonna utilize for flow equalization going forward would be used for flows above 4 MGD. So that would be a peak hour flow situation. Even your maximum day, you could potentially in the future, so this is in the 2050 development, you could do at the new facility without having to utilize this. But there is some advantage to keeping that facility open. It also gives you a fail-safe if there were ever a problem at the main plant for some reason. You could store quite a bit of this, or if there was ever a discharge, we've had that happen before where communities have had somebody discharge something we don't want at the plant that's toxic. And you can pause it and kind of collect it. So, it was decided to keep this facility, operational for storage and peak flow events. We're diverting the flow here with a gate and utilizing the existing lift station to pump over to both the 3 oxidation ditches that are in blue there, the kind of oval shaped tanks, and then also that circular tank is currently used for sludge storage. And that gives you about 800,000 gallons of storage at the site. So that can store that wastewater until the flows subside and we can take it back to the new facility for treatment. So there won't be treatment at this facility anymore, but it would be storage, which still means that it's part of the treatment facility.
From a storage standpoint, if you're storing wastewater in there, is there anything we would need to be concerned about as far as like odors, things like that could disrupt?
Generally, in this situation, if we're looking at it from a peak shaving standpoint, that's fairly dilute. We're getting the peak because of influence from surface water and groundwater. So we're sending flow there that's only going to be there for a short period of time. That peak passes and we can return that flow hopefully within a couple of days. So it's very short duration and it should be diluted. If we were looking at a situation, as Emily mentioned, where we were putting something in there that had some issues because we didn't want to run it through the plant, that may have some odor associated with it. But once again, we're doing it because there's contaminants in there that we don't want to run through the plant, and we have to be able to address that, whether that's coming in and pumping it and hauling it up to a facility that can handle that because they have enough volume that it's dilute enough, or whether we could bleed it back slowly and not affect our plant operation. We just have to make sure that we don't have what's called pass-through and interference. If it goes through our plant and doesn't get treated and goes out to the lake, that's a problem. We can get fined for it. So this is, it's handling a couple of things. One is giving you essentially more capacity with your existing plant because you don't have to handle those peak flows all the way through the plant. We can shave that off. So you get a little bit more growth capability. And then we also have the ability to protect the plant in emergency situations.
Then the next slide talks just briefly about the interceptor sewer. It's approximately 3,200 feet of 30-inch sewer that is sized to handle both the current flows that or I should say even just the future flows in 2050, but beyond that as well. And it's actually not that deep of a sewer. It's approximately 15 feet of cover at the existing site and gets to 10 feet or less along the new creek. As we move to the north there, when we turn to go into the new plant, it does get a little deeper again, but certainly that's preferable to any kind of pump situation. Anytime you can gravity flow within a reasonable amount of cover and construction costs, hands down the best way to go. And we also, in designing that, because of the depth that it's coming into, taking advantage of Mill Creek's continued decline through there, elevation wise, we are able to serve that area to the north and west, future growth by gravity rather than having to do lift stations. And potentially when that sewer is constructed, that is not part of this project, but when it is constructed, can take care of that lift station out of Trail Ridge. So finally, we reached the new plant at the next slide there. So the new plant, I don't want to get too far into it. I'm going to go through each process there, but the new plant site, we have a nice layout. The main process is kind of through the middle where you're going to follow, if you were following the wastewater flow, through the headworks to the aeration basin and into the clarifiers, and then down in that bottom left corner is the UV disinfection building on the way out to the creek. Along the north edge of the road there, we've got the solids handling process. So digestion, aerobic digestion, which is what's being used at the plant, the current plant as well. So that won't be a process change. We'll maybe make some upgrades to maybe be more efficient, but pretty much the same process there. And then one of the big changes that we are making from the current facility is we're going to be implementing some sludge dewatering to get it a little, right now you store it as liquid, or the sludge is liquid and it's land applied as liquid. In the future, it will be drier and will still be land applied, but it will be easier to land apply and require less storage room. And then there's a biosolid storage building there also. And then there's an administration and garage.
I have a question about that. Any big, is that building big enough?
Which building?
Are you talking about the admin building?
Yeah,
Um,
the last thing I wanted that thing to get done and then somebody come in here, see it's not big enough.
We'll get to that a little later and you can,
Or we're out of real estate.
Yeah.
I have no idea what they need. I'm not saying that. I just wanna make sure that we do this right the first time.
it's a great question, and they have some kind of areas of input they're gonna be asking for at the end of this presentation, and
Okay.
that's one of them.
Okay.
and then on the next slide, you can see the new plant future expansion. We just wanted to include this so that you understood that we did consider that. This would be, you know, we're anticipating 25 years or more before this would come into play, but there is room to expand that process. The headworks itself is being built with expansion capability up to 8 MGD. We're not installing that, but it has the space for future. And then also aeration basins, clarifiers can all be duplicated. So, I mean, this plant site is available for, you know, the next 50 years and setting the city up for future growth and leaving it in a good position. So on the next slide, we're delving into the actual buildings themselves that we've been working on. So this is the headworks building. So this is going to house the grit and the screenings that are missing right now from your current facility. If you look at there's a plan view on the left, so you're looking down at this building, and then on the right is a section through that. So the water will come in and flow through a screen. You see how low it comes in if you look at the bottom right. There'll be a big screen that brings the screenings up to the surface, but the water continues to flow in, and then it will flow into a wet well that contains those 5 pumps there. And we have looked at we're actually only installing 4 of those pumps. The 5th pump will not be installed, and the pumps that are shown there are actually larger than the pumps that you will have. That's all part of that potential growth. So you can replace those with bigger pumps in the future without having to, you know, add on to this building or revamp this building. And then flowing up, or actually pumping up to the surface, those big circles on the top of the plan view on the left, those are the grit units, and we're only installing one of those. There's 2 shown, but we're only installing 1 right now. The second unit, we're leaving space for a future unit to go in as the plant expands, but really only 1 is required to handle the flow that we're gonna see at that 4 million gallon per day flow rate. And there is a bypass built in. If there was some kind of equipment issue, they can bypass it temporarily. The big reason that we want to install the screening and grit removal really comes down to operations downstream. If you don't deal with that and take that out, you end up having problems in your aeration basins. It also can wear on equipment downstream. The grit can cause problems. And so any mechanical plant of the size of Solon's that would require or would incorporate grit and screening. And so that is one thing that we have been sure to include on this one. The next slide shows the aeration basins, clarifiers, and sludge pumping. So you can kind of see that we didn't delve too much into the inner workings of that, but you can see where it's located on the site. And that will be pretty close to what those aeration basins and clarifiers will look like going forward. And the sludge pumping is kind of located in between the 2 clarifiers. In some pits there's some submersible pumps And these basins will be what is the primary part of the biological treatment at that facility. The next slide shows the UV building,
The purpose of that is what again, I forget.
the aeration basins.
No, the UV pump.
So, DNR has completed, stream assessments and, establishes what your maximum, E. coli can be.
Okay.
And it's basically for human contact. So if there's a potential that a human would come into contact with that, they'll give you a limit for that to make sure that, you know, if you have a kid that goes and plays in the stream or something, that they don't get sick.
Sure, okay.
So,
I know it's brought up before, I just couldn't remember
yeah,
the why.
yeah. And again, this is a change from the current treatment. The current treatment, is chlorine. You add chlorine, you let it, 15 minutes of contact time with the water. That'll inactivate any organisms, but then you have to remove that chlorine so that you're not potentially damaging the stream again. So what they do here instead is use, lights, UV light to, inactivate, I guess I would say, those bacteria that are causing the problem. And
every plant we visited have this.
yeah, the
A
place,
similar system.
yeah, the places that usually do chlorine and chlorine anymore are usually near the Mississippi because they don't have to dechlorinate. Because the Mississippi has so much dilution, but Mill Creek obviously does not have enough dilution for that. So I don't know if I've ever done a newer facility in the last 10 or 15 years that hasn't done UV disinfection. It's basically changing light bulbs. So, it's much easier for the, operational staff to deal with, much safer for operations as well. And then finally, the digesters and sludge dewatering. As far as the process goes, this is kind of a side stream. So in those clarifiers, we settle those solids out. The solids go to the digester, where we add a lot more oxygen and try to let those basically break down and kind of eat themselves, use themselves as food. That stabilizes them, and then we'll send them through that sludge dewatering. So the picture in the middle is of an aerobic digester, just kind of a generic one, nothing specific to Solon. And then the one on the right, picture on the right, is of a screw press, which is one of the options we're looking into for this facility. And it basically presses those solids down and gets all the water out so that the storage is more efficient. Because if you think about, if you're storing a bunch of water, or if you're storing just the solids that are in the water, it takes a lot less volume to do that. And then go to the next slide. The administration and lab building. Originally, this building was intended to just be the part on the right. If you look at that, where the actual office space is. But after some discussion with the city, due to some changes that were made with the sale of fire station property, the need for storage of city vehicles really needed to be considered and couldn't wait until a future public works was constructed. So we've incorporated that as efficiently and cost effectively as I think we could. So when you look at that building, I believe it's too small to see, but I think we're in the 70 by 100 foot range for that building. So you can easily fit 2 vehicles too deep in those stalls. And so up to 6 vehicles can be stored there. And we worked quite a bit on this building, I think, trying to make sure we could accommodate the
Are those
need.
12 or 14-foot garage doors?
14.
I have a goofy question only because we ran into this at the new fire station. Most of that building have 20 or 30 amp breakers. You didn't anticipate that question at all.
We did talk with our electrical engineer. There's going to be some loads in there depending upon the use. You know, if you have welders in there, if you have power washer, if you have things that are going to have a high draw, we want to make sure we have the capacity to do that. Keep in mind that the main service for this is running much larger equipment, so we're going to have plenty of power there. It's just setting it up so that when we go through that needs assessment, which our architect has already looked at, we put enough power in there so that it can supply whatever they
Just
anticipate.
want to make sure, because we've had to change some things in the new building where if the architect would have listened,
Yeah.
we wouldn't have to.
Mhm.
So I bring it up now, just as a flag.
Yeah.
To make sure that, and make sure you talk to our people and what they think they may need, what they may plug in, not only today, but tomorrow.
So we do quite a few public works facility
Sure.
shops and have a pretty good idea based off of the list of items that get put in there, what those demands are, but we'll run through that and make sure that we kind of cover that and have.
Andrew, you proud of me for asking that?
Sure.
Andrew's an electrician.
Some days.
Well, and when we get the next round of plans too, and anyone that wants to can certainly take a look through, and we'd be happy to go through that with you guys and address any concerns if you have individual ones as well, but, I know we've had a few meetings already just on this building, trying to make sure we're addressing items like that. Then the last slide here, is just kind of a summary of the estimated costs. I think, you know, we have allowances in there for some of the wetland credits that we talked about. There's engineering and design fees, but the cost of the plant hasn't changed a whole lot as of yet. There are certainly some things that could shift around as we do get some of that information back, especially on that geotech. That's always a concern until we have that established. And there are a number of choices we can make going forward that are gonna impact the overall cost too. So that's kind of leading into our next part of the presentation, I guess. So we'll pause again if there are any questions on kind of where the facility is going and where. Is there anything?
The legal expenses, is that Kevin Olson, is that somebody else?
No, that is the legal fees that have to do with, the borrowing the money.
Okay.
So it's our bonding attorneys who prepare and review all the paperwork for the bond. And then there's also legal fees for the underwriting of the bond.
The engineering design fees from the engineering, observation fees, that's all Beanstra and Kim.
That, and we've got some subs in there, so Terracon is a sub to us, that's a cost that was in that fee. EOC is a cost that's in that fee. There's some other things that are included in there that, if you remember, we had that council work session, we provided that large spreadsheet that broke everything down. We had to do some hazardous material investigations, Terracon's in there for that as well. So, you know, we tried to break it down and be as transparent as we could, and we could go back and visit that if there's some questions, but that's all documented. How that fee was identified in that master spreadsheet. Just handing out, before we get into this next section, we've put together a rough rendering of how that plant layout looks, roadway, there's some trees, we're working to get this touched up a little bit, and this is the step before we do the architectural view, where you can kind of do the flyover, but we're near that point. It just takes a lot of time to get that built, but this is taking each of the buildings from the preliminary design, putting them on here, orienting them according to the plan that we have developed so far, and trying to get a 3D model built. So this gives you a pretty good idea of how this will look if we were to go down and look at it from the south side.
Okay, we'll move on to the next part, which is items for council consideration. A couple items have come that we feel like, we could use some council input on, and do affect overall project cost. Are the access road and driveway surfacing, so that, the materials that are used on the access road itself off of 382, and then also the driveway around the, new facility. We have a few options that I'm gonna present here with some costs in a minute. And then, also the biosolid storage building, I had mentioned we would get to that, in the earlier part. That's the building in that rendering that Dave handed out. That's the kind of that dark brown building next to the lab admin. There's some discussion about the material and also, the amount of storage that we need to construct. So, if you wanna go to the next slide there. Just to revisit this access road, because we have been through iterations already on this for design. So when looking at this access road, and the area around the facility, we were hoping to maybe be able to align that with Wyndham Drive to, with future use potentially, we've heard different uses, public works, rec areas, that kind of stuff. It seemed logical to us to try to align that with Wyndham and make that a regular intersection. That would require going across the property for the cemetery. I know Cami approached them about whether they would be interested in letting us do that as potentially a shared access for their future access to their site as well on their property. We were not able to reach an agreement with the trustees. I don't know if Cami has anything to add to that or.
They were open initially to the idea, of, the idea that it makes sense, that's a hill there. And so there can only be so many openings on that hill for visibility. We thought, Dave and, staff felt it was a win-win for them to be able to have, a nice road that goes through that potential expansion area of the cemetery, and then they could put some access roads off of that. They just felt that, they were giving up some space that they may need for potential burial sites. They were open to the idea if the city would help negotiate us, Watts Group giving that area where that, utility easement is going on the west side. They would be open it if the city could convince Watts Group to give them that in exchange for this. I don't think that the city, Dave and I did not feel that the city was potentially interested in negotiating additional property purchase at this time. And one of the reasons was that if it would delay our ability to stay on DNR's schedule. Not that it's not a future option, but for the reason of staying on schedule and not delaying the project anymore, we've just had to shift. And not that it can't be a future conversation, but we just need to pick a way and go. Is kind of where we're at on that.
So with the change, to locating it back on the city property, if you go to the next slide there, you can see the driveways just aren't quite aligned, but, they're to maintain access on our current property, that's what has to occur. The access road at the entrance is about 40 feet wide. It is a bit of a challenge to make that turn, especially with potentially, semis or some kind of equipment into that. So it is a little bit wider. We narrowed the road to 20 feet over the majority of that area on the north side to get to the plant. And we did kind of try to consider the potential for future widening as the area develops. So there's potential you could add a third lane, another 10 feet to get a 2-foot wide road. Again, it kind of comes down to what is the future use and how much will people need to get back there. Certainly 20 feet is sufficient for access to the facility.
Just out of curiosity, our standard street width now is
29 is pretty common. 29 to 31 is generally what we're looking at for anything that has significant traffic. We can go down. I think there's maybe some 26 footers coming out there that we've allowed. Those are more residential, low volume, but usually we're looking at 29 to 31.
So, and this road right now, you know, is just a road pretty much at grade, you know, a little smoothing to make the cars work out and maintain drainage, but otherwise, overland drainage across the road, just pitching it to the south. You go to the next slide. There were some surface options that we were, looking for some input on. Option one would be a full 7-inch PCC pavement, still not curb and gutter or anything, but just pavement, but obvious. And this is just the surface. This is not including the sub base. The sub base would be the same for all of these. And it's not included in that cost, but just the pavement cost alone would be $250,000 if you were to do PCC pavement. Seal coat would be 62,000. And then Class A roadstone, just a rock road, would be 33,000. And then we included the 7-inch HMA just because sometimes that is a question people have right now with all that's going on in the world. HMA is really not any cheaper than PCC. Those prices have been a little, you know, the binder ties the price to oil prices, and that's been a little volatile recently. So that price could go up or down, but I think, you know, looking at these options, it kind of comes down to how far out you want to project and the Class A roadstone, I don't know that that would be a great long-term option. You also have the concern with dust and potentially that blowing around, but it certainly, I mean, you can see the range in the pricing. Certainly there's quite a range. So
Do we know what, if we were to add curb and gutter to it, what that would add to the cost of the park?
It just depends on how we want to handle the stormwater. If we just had flumes that let it out, that would be a lot different than if we ran storm sewer along here and tried to discharge it. That's going to add a significant amount to the cost. So without knowing how that fits in with future driveways and everything else, you know, potential buildings for public works site, if we do a site out here for Parks and Rec, all of those things, we would probably be undoing a lot of what we do. So we really thought if we just did it as a smooth surface that they could just plow off to the edges and make sure we had drainage in certain spots, that was probably the least cost and probably best approach at this point. The curb and gutter doesn't really add anything in this situation.
And with the seal coat, knowing that we probably, if we're storing our dump trucks and things like that, any thoughts on how long that would hold up? No, it wouldn't be high traffic, but we'd still have some heavy equipment.
Yeah, and you probably have a few spots that are going to act a little differently as you plow it. Sometimes on seal coat, if you get a little bit of ridges, you tend to scalp those off. And then you have soft spots that form just from the irregularity of the soil, and you get potholes in it. So there's maintenance that's required. But generally the seal coat, as you know, from the streets in town here, every couple of years, you're usually looking to put another seal on. We just want to try to keep that from cracking and letting water go through. Generally the plan with that. So
you're gonna do this road, are we talking just up to this point right here? Because this is all concrete then.
yeah, so if you look at the next page, we're gonna talk about site driveway. So we're just talking about from the gate out to the 32 area.
My gut tells me even though paving is more expensive up front, it would save us money and probably headache and maintenance in the long run. It's my thought.
I think something you have to consider is, are the snow plows gonna be stored out here? Cause they're gonna have to plow their way out and in, you know, kind of depending. I don't know that we've really had that conversation internally yet, like what would we actually house here first, you know? Can we put the plows at the current shop? But in the long range plan, if there's gonna be a plant out there eventually, or I mean, a shop out there eventually, then I think there's a strong likelihood that the snow, at least part of the snow equipment's gonna be out there. So you have to get there and then you have to plow your way out of there for staff. So I don't know, if there's an opportunity to do something now that sets a base for later. Um, that might be something, just a conversation that we need to talk through internally as well.
And we don't need an answer today. It's just something for council to consider, maybe talk through with the public works staff. See what your thoughts are as far as cost setting measures. Is this one of the places we'd look to? If we get to the end and we say, hey, we're a little bit higher than we were anticipating, where do we want to try to shave cost? This is one of the easy ones. It doesn't affect the plant performance. And it's something that if we do future improvements out there, we can upgrade it at that point.
The next area that we were gonna talk about too was the side driveway. You can kind of see on the rendering that was shared too. A lot of these, so you have to have access to these to haul, like in that Headworks building, the dumpsters, there's dumpsters that have the solid, they'll need access there, and then most of the buildings along the north there, will be drive-in buildings. So in the sludge dewatering, what they're planning to do is when it comes off that screw press, it's gonna go into the back of a dump truck. And then that truck will drive around and dump it over in the biosolid storage building. So you got a lot of turning movements and stuff through there. Certainly the existing plant right now, I believe, is just HMA. So asphalt around the loop for the most part. I would recommend a solid surface on that main drive for sure, where you've got those movements going on. If you look along the south side, the kind of the bottom loop there that goes south of the aeration basins and the clarifiers, that loop, I mean, talking with staff, and they're not 100% convinced that they would have to have that surfaced, or if they did, could a rock surface be used there? I guess that's something we would again look for you. It kind of comes down to the items you've hit on with even with the access road, long-term maintenance and that kind of thing. Oh, and most of the decisions we make in this facility really do come down to that too. Oftentimes we have to spend a little more upfront, hopefully to save a little maintenance on the back end. So something else to kind of be in that thought process too would be, maybe that would be an area that would be appropriate to be rocked, or a compromise in some of the other surfaces that we're looking at. If the main drive is go the PCC route, that's still an area where we've got savings, and it's not a huge amount, but it's something that, again, when we're having to make decisions and cuts, sometimes those are the easy places to pull from. So
Do you have numbers for this area like you had for the?
I didn't do the numbers because I just wanted to kind of present that right now. And we can get you numbers on that too if you want, but it would be less than the driveway numbers.
The other thing to point out on this is if we were to expand this plant for future, when you looked at that, it was just taking the aeration basins and clarifiers and stamping them south. So that road would come out at that point. So if we do put it in gravel now and we end up doing something 20 years down the road, not like we're having a huge impact if we have to displace some gravel.
So those were kind of the two areas we want to talk about as far as paving options and stuff, and get some input. Like as Dave said, not necessarily don't have to have it tonight, but something to be thinking about, and we may be approaching that if other items start to increase in cost too, that may impact that decision. The next item that's on the list to discuss with you is the biosolid storage size and the building material. So the current size of the biosolid storage is 59 feet by 73 feet, which is what's shown on that drawing that you have, the rendering. The size, it's sized to hold 272 days of biosolids at the full 20-year design. So keep in mind that the existing facility is about a third of the size of the future facility. So right now, if you had 270 days of storage at that full design, I mean, take that times 3, and that's about how many days of storage you have. So it's a lot of storage. DNR does require us to have 180 days of storage at the full design. But certainly that's 100 days. I mean, what we're showing right now is 100 days more. I've yet to be to a facility that complains they have too much storage, but um, we just wanted to present this as an option. We could look at, you know, downsizing this building. There's also a number of different building material types that we could look into. I'll go through the pre-engineered metal building, the wood post frame building, and the hoop building on the next slide. A little bit more in detail. The next slide is the pre-engineered metal building. We included a photo just so you can kind of get an idea. Don't get confused with all the conveying equipment that's there. That's additional, and that's not part of our design. But I did want you to be able to see, so in case someone was not familiar with what these are, the pre-engineered metal building would be all steel construction, 50+ to 0-year design life. But it does come with a pretty big price tag of about $400,000. That we have it, this facility chose to move that direction, see it more on really big facilities, or big plants. Another option would be, a wood post frame building. More similar to what you've seen, around here, you know, outbuildings and, similar. And all this is storing is, you could see it back in the previous slide, but all it's storing is, biosolids material, so looks like dirt basically when you're out there. And we've done a number of these wood post frame buildings as that storage. Now, obviously, a post frame building has wood structural members and not steel roof, and steel roof and wall panels, but wood structural members. So there is some reduction in the longevity of that building and additional potential maintenance related to anything that you build out of wood and leave open to the air. You know, when you do a post frame building, often those manufacturers will give you a 40-year warranty on the building. But it is less than a pre-engineered metal building design life. And then using that same size, this building is only roughly $150,000 rather than the $400,000. And then the last option, biosolid storage, hoop buildings, you've probably seen those, whether you knew that that's what you were seeing or not, but I've seen those at a number of facilities too.
What do we do with the biosolids? Is this a cycling thing?
So biosolids, they have to be hauled off. Most towns land apply them, so they'd have someone, one of the sledge haulers come out and land apply them. But obviously, when they're land applied on farmland, there's only certain times of the year that you can do that, and be in the field. So that's where that 180 days of storage comes from.
You have to wait till the crops are out, or you have to wait until spring where it's dry enough you can get on the field, but before they plant. So spring is usually a pretty difficult period to hit.
So buildup of these things is, but
You have to have,
strong risk.
yeah, you have to have enough storage there that if your window shifts a little bit, you can accommodate that. So that's why instead of going exactly 180, you're kind of pigeonholing yourself into those tight windows. If you could build a little more storage, so you've got some flexibility. Now, keep in mind, this is the design year, so this is 20 years out when we're at full plant capacity.
Which is, the full plant is 3 times what the current plant loads are. So, and then this last building is a hoop building. And this is from a community not too far from here, actually. And, obviously it's just a fabric over, a steel frame. So you can imagine how that holds up, which is, you know, it functions, but if you have a big windstorm or something come through, that'll get torn off. And it'll degrade over time. So the fabric life is, you know, 15 to 25 years, assuming you don't have a major storm that would cause damage, or just over time, it'll degrade from the UV. And then the steel also will degrade just at a slower rate. But it's a substantial cost savings, you know, 64,000 roughly for this same building. So again, this is an item where, you know, the treatment process itself isn't heavily affected. you could, scale the building down a little bit, it would still probably be fine for Solon, and there is an opportunity, I mean, especially if you went with, well, even if you went with a smaller building, you could potentially build again in the future. Since it's trucked into this, it's not tied to a specific location on the site where it has to flow or, something like that.
But these are just open air buildings, like,
Yeah, nope.
biosolids, there's no methane or anything
Nope.
like.
It's just like, it's like you're piling dirt around, and it doesn't have an odor. It should be stabilized by the time it's there. There's not really an odor associated. You can walk up and stand next to it and you're not gonna. Yeah, I don't even think it smells. I mean, I don't.
It's a little bit of an earthy smell, but that's
Yeah.
about it, yeah.
But you can see there, they had one building and then they just constructed another one, next to it when they needed more storage. And stuff like that is always an option, as long as we meet that 180-day requirement, we can't go below that, but certainly the 270 days that we're looking at right now isn't a requirement. It was, it's always nice to have a little more space. Some of our communities have gone to just wanting 360 days of storage, just to have that available, and they usually find it. Most of the time what happens is it's just more storage as they grow. They don't have to expand their storage as quickly. So those are kind of, the next slide kind of summarizes those three options. Again, down to, maintenance costs and capital costs. So the items that are more likely to have a shorter design life, lower cost, and the items that have the longer design life have the higher costs associated. So something to be considering.
One question I have, it's not so much over the type of building, but between the sludge, the digester and the biosolid storage, those three buildings.
Mhm.
Is there room to move those to the west, further away from the admin building? I'm just trying to think. If there's expansion,
Back to the separation.
those are moved down later west, could we add on to that garage? Is it cheaper to do in addition to a garage facility?
This one?
And I don't know how long we can get moved based on property. But that's one. Good question. One thought that I.
Yeah, so this one, Dan, shows what we're dealing with. So if you look at the site and you look at, right around the wastewater plant, there's that bold pink line. That's our distance that we have to stay within based off of that 1,000-foot. So anything that isn't considered an open water surface, that would be part of the treatment process, or a treatment facility building that would potentially create odor, we can move out there. So for example, if it was a storage building, we can build out there, but if it's part of the treatment process, we can't build outside that.
Is it something where we could take the admin building, right now it's on the right, if we were to move that all the way to the left and shift things over, or does that create other issues?
So a couple of things that we talked about with this, let's say, for example, that we wanted to purchase that lot from Watts to the north at some point down the road, and there was a need to build up there. We would want to come in on the driveway, come up off the side and go up there. There's a lot of grade difference in there. We can make that work, but we don't want to get into the trees too much. There's also a stormwater impoundment easement as we get to the west side of that lot. So there's a lot of influencing factors to it that aren't shown on this drawing. The other thing is that, in discussion with staff, they wanted to, as they come in, have that lab building there so that, let's say we have a septic hauler or somebody else that comes in, that's noticed right away. It's not somebody comes in with a site and they're not noticed right away. We can do things with cameras and whatnot to help out with that, but that also puts that lab building close to the aeration basin and the headworks, which are probably two of the more frequently, accessed buildings out there. We've got, the grit removal, we've got screening, we've got things that are going to require daily. There's a sampler out there. All of that stuff is going to be close to that admin building, by having it up front. If we push it to the back, now you're increasing your travel distance for every trip you have to make there. So that was discussed quite a bit, and they would prefer to have that admin building at the front of that plant in that location for those reasons. We could do it, it's just not, from a functionality standpoint, they prefer not to do that.
I'm just trying to think of if there's expansion and going back to Greg's thought, but looking at tomorrow, if Public Works is all of the facilities, the garages, everything was down there, what would be the lowest cost?
Yeah.
Expand or things like that.
As we grow with the wastewater facility, the garage space that's in there might house, if we get a jetter truck, if we get some other equipment, if they're going to start to do some repairs. Different things like that, you might have more equipment in this building that are associated with wastewater. And the public works might be outside of the gate of this wastewater plant and be on the south side of that driveway. And you can put a flex of buildings there that would house public works. And that way their facilities and their activities aren't impacting what happens at the wastewater plant. We're not going over top of each other. That's probably the biggest thing that we see when we get into that, especially in wintertime, when there's a high public works traffic. And the folks at the wastewater plant where we have those joint facilities, there tends to be a little bit of a jockeying for space and parking, and you get all the guys in to go plow that. For parking and whatnot, it kind of limits the space. So that's the complaint that we generally see when you try to combine them too much. This was really set up so that we could use it short term for some storage, but it's not really intended to be for public works. It's more short term, take the place at the fire station, provide some overflow if we need to, but grow into it as part of the wastewater facility. And have an outside of this, have room for the public works, make sure that we have that site available for expansion.
That entire building needed.
That building is heated. We were looking at radiant.
Yes, that's because I went through an extensive study with the firehouse. It doesn't pay. So I agree with radiant heat.
We got Dave Richards on Zoom. He's in training in Des Moines. He's gonna be the one who's housed in this facility. And so he's had a lot of comments and input through the process. Did you have any, talked a lot about the design of the lab, the offices, the space needed. Any comments you wanted to share with the council, Dave?
Just that, can you hear me?
Yes.
Yes.
Just that there's been a lot of time and energy put into this. To make it easy on the operators that are going to work there in the future, try to keep the staff to a minimal. The more spread out you get, the more more staff it takes to monitor all these things at once. Granted, there'll be a SCADA system in there where we can watch it from a computer, but you still have to put your hands on things and to be farther spread out. And there's been a lot of thought gone into how this is set up, and we're not asking for a bunch of extravagant things. It's just to make it as efficient and so we can produce the best product that we can produce with the best cost to our customers.
That definitely feels like there's been a lot of thought going into it. I just appreciate just the collaboration that's been taking place with this. I think it's exciting to see, and we definitely have some things to think through as far as road surface building type things like that, but feels like it gives us a good start.
And there were some on the admin building, there's some material options. That'll be presented to the council as well to decide, what does that building look like? Does it, I think the intent as shown, is it the admin part's concrete? Is that right? Tentatively?
I think it's block.
It's a block, and then the rest of it is metal. Yeah.
It being block for the admin portion, would that provide for a good, like a storm shelter or something like that? If it's or not there, would it be rated for that?
It's more resilient than the metal building, clearly. That was one of the discussions, is that's where we're going to have the control panel. the brains for the system here. We want to make sure that that's more resilient so that we don't have a storm come and do a lot of damage to that. We want the plant to continue to operate. Whereas the sludge storage and, the storage building there being metal, that might not be as resistant as a block building, but you see that a lot for those types of buildings. And from a cost standpoint, if you've got to do some repairs on that, that's not functionally going to change the operation of the plant during that period. It just, you might have to do something temporary until you can get it rebuilt through insurance. But yeah, the Headworks building, the sludge press building and the admin building, and the UV building, those are more resilient materials, tilt up concrete panels, a little bit better as far as, making sure that if we do get a storm or if we get hail or something like that, it doesn't have the susceptibility that some of those others would. Now you get the hoop building out there, for example, and you get a hailstorm, you're probably going to have a new tarp out there. That's not a big cost or a long, lead time on it, but it's just going to be more of an issue as far as having to replace things if we go with something that's a little less expensive up front.
But as far as if any of the public works crew is out there working and tornado pops up, we would have a safe spot for them to go.
So there was discussion during this design where we talked about, because the roofing material is still, we're still looking at a wood truss or a truss type roof or maybe a metal roof, but there's still some potential there. We talked about reinforcing maybe one room, like instead of doing the whole building, but certainly trying to make sure that probably the one SCADA room.
That one shows the building,
Mhm.
admin lab building. So you can see on the floor plan on here, there's some rooms that are a little bit narrower with block walls. Those are going to be a lot better as far as, the SCADA room, the shower room, some of these offices, they're going to be in an area where if we wanted to do something to make it a little bit more of a storm shelter, we could add something to that.
I think that's paramount.
Yeah.
We need something out there.
Yeah, and that was part of our discussion, because we were concerned about resiliency, especially with all the derecho stuff and the tornadoes. It seems like they come through here periodically.
And I understand not having an entire building, but I want to make sure that
Right,
there's
no, I agree.
space where, building for the future, we have, 6 on the crew right now. For some reason, all 6 of them are out there.
Yeah.
We have a spot that all 6
Yeah.
can safely be here, even if you should say double that,
For sure.
that there's a safe spot for them.
Yeah, I think if we look at the SCADA and the ADA and the shower area, and we made that, so it was, somewhat of a storm shelter by putting something, maybe a little thicker walls and also doing something to the roof that if the main roof comes off, there's still something there for protection. I think that's what you're after. Yeah,
Yep.
okay.
Thank you. Other questions or thoughts that?
Kind of let you guys know that our next steps, we're planning to go, we actually had a facility visit planned for, Coralville earlier this month, and they had an issue at their plant that they couldn't, do it, but we will be doing another tour to go through some more, in detailed building decisions. It's always helpful to visit another facility and be able to point at like, these stairs are like this and, that kind of stuff so that we can make decisions. We'll be doing that here in the next couple of weeks, I think. And then there's still some equipment selection going on. But generally, we're just down to picking systems at this point, and then 60% plans should be by the end of August. So any input you guys have, or if you have any questions, feel free to pass them through Cami to us and we can take care of them.
Thanks a lot for going over all that with us. That puts us to motion to adjourn. Okay. Motion by Gordon, second by Morris. All in favor, say aye.
Yeah.
Any opposed? Meeting adjourned.
Okay, Dave, bye.
Bye.